All right, so here we have the dot convention reference that I kind of put into this slide. Looks like a lot to think about, but really there's only one thing that you need to think about, and I'm going to write it down. But what they're basically showing here is they're showing all four combinations of dots, but they're showing it with all four combinations of currents as well. So you've got all these different possibilities that they're kind of showing you, which I think is great because once you understand the thing that I'm going to tell you, the one thing that you need to know, you can kind of back check to make sure that it makes sense by checking if what I'm telling you and your understanding of what I'm telling you is consistent with all 8 of these cases. And it should be the case, okay? So what they're saying is, if I have the 2 dots up top on my coils and I have an inductor or a current I1 flowing into the dotted terminal of L1, I get a positive voltage at the dotted terminal V2, okay? And so if I flip the direction of that current, so now instead of that current flowing down through the inductor, I say that current's flowing up through the inductor, but I keep the dots the same, that flips my polarity of my voltage, right? Then they basically show down here that if I keep my current the same and push one of my dots from the top to the bottom, right, which is this case down here, I get negative voltage. And if I both flip one of my dots and flip where my current's flowing, then I get positive. So this is way too much to think about. I don't want to think about this. I'm sure you don't want to think about this. So all that I ever think about is this one thing, and I'm going to write it right here. Positive current into the dotted terminal of one coil forces positive current out of the dotted terminal of the other coil. Okay? And so we can see that. Let me rewrite the word dotted. Rewrite the word dotted here because I think that it's pretty ugly there. I wrote this. This is the rule. This is the one rule that I use to solve these circuits. It helps me to set up the equations to never get the polarity wrong, and I think that you will find it useful. So what is it saying? Positive current into the dotted terminal of one coil forces a positive current out of the dotted terminal of the other coil. Okay, so let's take a look at the first case here. I do have a positive current flowing into the dotted terminal of this coil. So that should force a positive current out of the dotted terminal of the other coil. Okay, so that's saying that if I were to basically connect a load here, I should get a positive current flowing out of the dotted terminal here. Let's just call it I2. And that is consistent with what I see for this voltage polarity, right? If I have a positive voltage here, V2, across this resistor, Ohm's law says that current has to flow out of this dot, right? Because it's going to flow out of the dot down through the resistor, assuming the voltage polarity is plus to minus here. So that is consistent with this reference chart, okay? So that's one case. Let's go take a look at some other case. You could also say that the inverse is true here. You could say positive current out of the dotted terminal of one coil forces a positive current into the dotted terminal of the other coil. It's basically just reading the sentence backwards. So if you ever see a case like this one, where positive current is flowing out of the dotted terminal of one, it's going to force a positive current into the dotted terminal of the other, right? Here's the dotted terminal. I have current flowing. I should have current, since I have current flowing out of the dotted terminal here, right? It's flowing into this undotted terminal and out of the dotted terminal. That means I should force a current into the dotted terminal of L2 and out of the undotted terminal, right? And so again, if I were to connect a load here, this is consistent because this voltage polarity is telling me that it's positive from plus to minus right here, which means with passive sign convention, I would get current flowing down through this resistor, right? That's consistent with my little scheme here, okay? So far we're 2 for 2. This should work for all 8, okay? There's no exception to the rule. It's just a matter of applying it and understanding it. Let's do one more. Let's check this one out. So again, positive current into the dotted terminal of 1. So we've got positive current into this dotted terminal. Should force a positive current out of the dotted terminal on the other coil, which means I should get current flowing like this in this circuit. And that is consistent with me connecting a load right here. And if I'm assuming current's flowing this way, then I should be saying that the voltage polarity is plus to minus in this direction, and they're saying that the voltage polarity is plus to minus in this direction, and they're getting a negative voltage, which is exactly what we should expect to see. Okay, so this is the dot convention. This is your dot convention reference. I think that this is probably sufficient. I think it probably will just help us more to start solving some example problems. But let's go ahead. Actually, I'll leave that in there just in case you want to see it. But I'm going to go ahead and end this video. I have another slide here for the dot convention, but I don't think that we're going to need it. I feel like I've spent quite a bit of time here showing a couple different examples. If I can't think of any other examples to do right now right here, I think I wanted to start solving book problems. I think that that'll be the best way for us to learn, kind of see the process for these problems and how to solve them. So I'll just go ahead and end the video here. If you have any more questions about the dot convention, which I'm sure you will because I know it's confusing, please let me know. Happy to answer those and try to get you to a point where you understand it, okay? Because I totally get it. This stuff is not super intuitive at first, but let's hack away at it and see if we can make it make sense. All right, so I'm going to end this video, and we'll see you guys in the next video.